So I met Dave about 2 years ago. I had started to look into the ES6 module system, and I also was about to start joining TC39, which was definitely one of the most scary things I've ever done. And I don't remember exactly why, but Anton wanted to talk to us, and so I sat down with Dave, and I basically said, Dave, here are my 47 doubts about ES6 modules. I had started looking into ES6 modules for possible use in Ember. And thankfully, I didn't. It's easy when you talk to a standards person to say that and then be a hater and basically lob a grenade into the room and drop the mic. But thankfully, I was in a good mood that day. And so I talked to Dave. A year later, I actually became one of the champions of ES6 modules, together with Dave, who had been working on it for like 17 years at that point. And I think both Dave and I have been on a journey to, Dave comes from a somewhat academic perspective, and I come from a hardcore developer perspective. I've only been programming for 7 or 8 years, and I think we've been on a journey together to figure out how to evolve the web platform, make developers happy, and I think the perspective that Dave will talk about today is sort of it's unique in the sense that I think all of us who are working on the web platform are starting to converge on an idea for how not only the platform could get better, but how we as developers can help make that happen. And so I'll give it to Dave. Take it away.
All right, thanks. I got my own. Yeah, I'll put this away. All right. Testing. All right, am I on? Yeah? Okay. So thank you very much for that intro. And I just want to say thank you all for welcoming me here. This has been an incredible joy. I've been to a lot of web tech conferences at this point, and I guess everybody says this kind of thing, but this really feels different. This is a community that seems to genuinely care about quality, about design, about thoughtfulness in how they put things together, and also about each other. And I'm just really excited to get to spend these 2 days with you guys. So, so thanks. Yeah. So I want to talk about evolving the platform, just like Yehuda said. So evolution is the topic of the talk, and in particular, I want to convince you that evolution is awesome, as are Keynote animations. And of course, evolution's kind of counterpart is revolution. And revolution is really attractive. It's really fun to reach for that fantasy of, man, if we could just do this all over again, how much better could we make it? But this is not going to be a talk that tries to convince you that revolution is wrong. Sometimes it takes a revolution. Sometimes you have no choice. As an example, I was recently digging back into some of the early history of the web, and there is some really incredible drama that went on back in the late 90s. I don't know how many people know this story. I knew some of it, but not really all of it. And there's this fantastic documentary called Code Rush that tells some of this history. In 1998, Netscape was dying. They were being squeezed out of existence by Microsoft, and they were doomed, and they knew it. And you can see in this documentary, they were very explicit about this. They knew they were dying, and it was quite possible that if Netscape disappeared and there was just no alternative to Internet Explorer, Microsoft really could end the web, or at least let it stagnate and not get any further. So they plotted a revolution. The crazy idea that they had was that on 10 a.m., March 31st, 1998, they actually had this timed to the minute, Jamie Zawinski at Netscape was going to push the source code to Netscape out onto the web and create the first big open source browser movement, creating the Mozilla web browser. So here's just a little bit of that history. Let's see how the sound is.
Put a person out 26 miles into the desert and say, you know, that there's this bomb on your back that's going to go off in a certain length of time if you don't get into the town. well, that'll motivate you to get in, but there's a certain chance that you'll be blown up.
So watch the ticker in the bottom right corner. We're 5 minutes to 10 a.m.
Welcome everybody to the conference call. Thanks for joining us this morning. Today, Netscape announced that the first developer release of its Communicator 5.0 source code is available for download from the mozilla.org website.
And you know where Tar is. That's right.
So that's Jamie Zawinski there on the right, if you're not familiar with him.
And then today, on the end of March, as we announced, we are pushing the code out to the web, as they say, and we're delighted to be part of it, and we're very excited to see what happens.
The good news is the marathoner is now coming into town with that bomb on his back, and it looks like he's going to make it.
It was very hard for them to meet their shipping deadline.
This is the moment of truth.
They don't have a theoretical framework to write software, they're just writing it.
Hi.
It's just like hitting the baseball. If their code gets a home run, nobody's asking questions. Well, this doesn't make sense, or why do you do that? Why does it work? Nobody cares why it works.
I'm pretty sure they knew what they were doing here. They were about to rescue the web.
Wait. Bad.
What's that? Well, it's not connected to
the machine that controls the FTP push is like not answering.
Is it Lotus?
It's Blast, not Blash.
Oh.
Yeah, maybe.
Okay. Yay.
It's super.
Mac's there. Linux is there. Windows is there.
We're done.
We're done. It's up. We're done.
Since Jamie is here, I'm told that means that we have now pushed the source out on the net. Is that correct?
Actually, we decided not to.
Any fun?
It's just a stupid idea.
That's our story, and we're sticking to it.
For a moment,
I think that was Andreessen.
everyone at Netscape takes a breather.
I think it's going to work out. All right, I think it's going to work out too. So not long after that, Netscape did in fact go down in flames. It got acquired by AOL. The company slowly kind of dissipated from relevance. And a lot of people were getting upset. And Jamie Zawinski wrote a blog post about a year later reminding people the importance of what they had done. He said, remember, no matter what AOL does, no matter what the corporation decides to do, they can't undo what has been done. The Mozilla code is out there, and nobody can ever take it away from you. So this was a revolution that mattered. This was a place where the web was about to die, and they knew it, and or at least it could be about to die, and they had to save it. And so, like I said, as tech people, we really like to think about doing things all over, doing things better the second time. And sometimes you have to do that. But sometimes it's just kind of like, we're tired of these warts. JavaScript has all sorts of WAT in it. We really wish we could just do it better again. So one of the common kind of revolutionary calls that I hear a lot is, why don't we have a bytecode VM for the web? So I would characterize that as a revolutionary call. That's basically, can we throw away JavaScript and do a new kind of target language so that people can compile to the web? So people can compile to the web, right? People do, and they have for a long time. The only thing is they can only compile to JavaScript. So really, it's not that they can't. It's more that there are issues with JavaScript as a compilation target. So when you actually start to drill down, it's not so much, well, there's a particular binary format that would be nicer than JavaScript. Like a compiler is a computer program. It can generate whatever syntax it wants. That doesn't really matter. When you dig into it, there are some things about JavaScript that make it suboptimal as a compilation target. So it lacks features that you need for other programming languages. It's slow, or at least sometimes it's slow. And so sometimes it can be fast, but it's unpredictable when it's fast. So one of the constituencies that really cares, one of the markets that really care about compiling to JavaScript is the games market, where they're shipping games to multiple platforms. They would love to be able to ship their games to the web. There's a lot of benefits to being able to ship their games on the web, but they really need predictable performance, because if you're in the middle of the game and suddenly you hit some sort of jank based on a de-optimization in JavaScript or some code that accidentally failed to JIT, or maybe just the JIT itself can cause jank because running the compiler can be user visible. So these are all concrete technical problems, but instead of just throwing away JavaScript and starting over from scratch, at Mozilla, we decided to try an evolutionary strategy. So it started by an experiment called Emscripten, which was, let's build a native to JavaScript compiler. So it's not actually a C or C++ source compiler. It uses LLVM, so it leverages a lot of pre-existing work in LLVM. And that means actually any language that LLVM can compile, you can compile with Emscripten. And so we saw, okay, well, how well does this work? And it actually worked better than anybody expected it to, including Alon Zakai, who is my colleague who actually was the inventor of Emscripten. He kind of never expected it to be as successful as it actually was. The next step from there was, okay, now we're generating this code, and it's actually running faster than we thought it would, but let's look at the code patterns that it generates and find out where the optimization faults are, find out where it's too slow, and then work on the JavaScript engine to try to close those gaps. And the final step was a project called Asm.js, and with Asm.js what we did was we said, okay, now that we have a pretty good handle on what this pattern of code is, can we actually formalize it with a spec, and can we recognize that sort of subset of JavaScript with a validator directly in the JavaScript engine, and then do some even more hardcore optimizations on the validated subset of JavaScript. So all of this was a step-by-step process of improving JavaScript as a compilation target. The critical thing from an evolutionary story is that every step of the way we were dealing with JavaScript, which means that every step of the way we were dealing with something that worked across browsers. Now, it could be faster in one browser than another browser, but some applications might actually be a little too slow in one browser over another one, but over time, the set of applications that become acceptable in terms of performance gets larger and larger, and meanwhile, there are lots of applications that you can ship across browsers. So we spent a lot of time with the games industry saying, look, this is real. You actually can compile your top-flight games to the web without plugins. And that without plugins piece is the key, right? That's the part where they get to say, like, hey, customer, just come to my URL. That's it. I don't have to ask you to install a plugin to the browser. I don't have to ask you to download an executable that's probably totally unsafe and run it on your desktop. So this is real, and I'll just show one demo. Let's see. So one of the game companies that we worked with is Epic Games. They're one of the top names in AAA games, which are like the Hollywood budget games. And they have a game engine called Unreal Engine. And the latest version, which I think hasn't even come out yet, is Unreal Engine 4. And they have been working with us for a while now, a couple of years, porting Unreal Engine 4. This is millions of lines of C++ code that's running in your browser without plugins. So you can see all the 3D graphics, that's WebGL. The sound is web audio. And of course, all that logic is just JavaScript. Now this runs best in Firefox because we've done these extra optimizations, but it also runs in Chrome. Well, I'm not sure if this demo runs in Chrome yet. I don't know if it's been tested, but. And these definitely tax the JavaScript engine, so it's work in progress. So I think this is evidence that it doesn't always take a revolution, that sometimes evolution can get us there, and it can get us there pretty fast. All right. Okay, so that's Asm.js. Thanks. It always feels funny getting applause for this technology, which I did not build myself. So all credit goes to the people who did WebGL, Web Audio, the implementer of our backend, Luke Wagner, the implementer of Emscripten, Alon Zakai. There's just a lot of really fantastic engineers who built that. All I did was help with the spec. All right, so the next topic I want to talk about is 1JS. This was a slogan I coined a couple of years ago. Look at the bad old days of JavaScript, which was when I first joined, and I've learned a lot since then. This is like 8 years ago. We were in the process of doing edition 4 of ECMAScript, which is the one that died. It's the one that didn't make it. And back then, the plan of record was we get to, as designers of the language, we get to just throw away all the constraints of compatibility and think about this glorious new future where we can really make JavaScript the language in our dreams and throw away all the things that we don't like, and everything will be great. But the way to do that, the only way to break compatibility without breaking the web, was we were going to have an opt-in. And so the plan was there'd be a new MIME type, which was something like application/JavaScript version equals 4, which sounds like a really fun development model. But it was going to be great. Everyone was going to love us. So we were going to get to do things like add this idea of generator functions. And at the time, we were like, oh, well, we can design a new syntax. We can break compatibility. So a generator function was just going to be a function that had the yield operator in it. But actually, yield wasn't a reserved word in JavaScript, which meant that this was backwards incompatible, because what if you had a variable called yield? No problem. We got the new MIME type, so who cares about compatibility? I'm sorry. We thought this was a great idea. So this died. ECMAScript 4 died. Not all of the ideas from ECMAScript 4 died. As probably a lot of you know, generators are actually a part of ECMAScript's edition 6 that's coming out. So there was an edition 5. I was actually really busy in grad school at the time and didn't participate much in edition 5. But after edition 5, we were like, okay, let's work on the next grand revolution, the next glorious ECMAScript, and it was going to be version 6. And so we were going to get it to throw away compatibility constraints and make it the perfect language of our dreams, and it was going to be great. And so it was going to have an opt-in, and this time it was going to be better because it was going to be application/JavaScript version equals 6. So this seemed like a good idea. I was, just as we were going through the iterative process of fixing the design, and little by little things were actually looking more and more compatible, and it was really fitting closer and closer to the existing JavaScript development model. My friend and colleague Sam Tobin-Hochstadt, at the time he was a PhD student at Northeastern University, now he's a professor at Indiana University. We had this mind-blowing IM conversation where he said, I really feel like we are so close to actually being fully compatible. Do we actually really need this version opt-in? And it was like this big aha moment for me when I realized that we were idiots. We'd been doing it wrong all along. And what we really needed to do was, if we were going to add new features, we needed to add them in a way that was backwards compatible, so that we didn't have to require an opt-in, and we could smooth the evolutionary path. We could smooth the migration path for developers to be able to start adopting features without having to worry about, if I just want to use this one feature, do I have to now suddenly move into this entirely different programming language? And what kinds of incompatibilities might that introduce? What kinds of hazards might that introduce for my code? So I sent this email on New Year's Eve a couple of years ago to the TC39, or to ES Discuss, and I was like, oh my gosh, this is amazing. We can actually build an evolutionary path, and we can actually just have one JavaScript, and that became the slogan, 1JS. And this is really important for several reasons. One is focus. It's too easy for designers to want to kind of go off the rails and dream about all sorts of big design boondoggles where they can kind of reinvent the universe. And it's very hard to focus the conversation when everybody's going off in their own direction. It's really critical for the development model for being consistent. If we're adding new things to the language, it has to work with existing code. It has to be orthogonal and composable with existing features of the language. And all of that adds up to the ability for people to adopt new features without fear, to adopt new features without the fear that that's going to break their existing code. And even if it's not going to break their existing code, it's hard for them to know that for sure. So we really have to have as few kind of evolutionary hazards as possible to make it as cheap as possible for people to pick up on new features. And of course, when you're talking about a language, a lot of this stuff can't just be shimmed with a pure polyfill. A lot of it requires actually using a compiler. The first time I went up in front of an audience, I think it was 2010, saying, I think we can make evolution work better if people are willing to work on precompilers. I was super sheepish about saying this because at the time it was like, okay, there was CoffeeScript, and so I thought, well, it's plausible, right? Like maybe if somebody was really ambitious, they were really willing to put in the work, they could build a compiler. But I sort of assumed that nobody was going to take that seriously. At this point, everybody takes it seriously because this is actually how, in particular, you guys work. This is how we're actually pushing the web forward, is we're working together with standards and with developers to try out new features in actual working implementations via compilers. So this is, I think, a crucial part of the process, and you guys are at the forefront of doing that important work. So actually, there was another little sort of non-default opt-in that happened in that time in between ECMAScript 4 and ECMAScript 6, and that was this use strict thing. And my understanding is that use strict is pretty widely used within the Ember community. But if you think about like Tom and Yehuda's talk yesterday, where they were saying it's really important for people not to have to make choices to do the common things. This idea that they've talked about in frameworks, that frameworks should make it feel good to do the right thing. Use strict is the opposite of that. We want use strict to be the right thing. It cleans up some of the warts of the language. It also fixes some compatibility issues. So for example, one of the most painful warts, at least from my perspective, of ECMAScript is that it never standardized what a nested function declaration inside of a block means, and it's completely incompatible between different browsers. They actually implemented it even though it wasn't in the spec, and they implemented it differently, and it has really subtle gotchas about its behavior. And strict mode kind of cleared that path. In edition 5, we actually disallowed it to prepare for edition 6, actually giving it a compatible semantics between all the browsers. But if the only way that you can really use that in a compatible way is that you always have to opt in to use strict, we got the defaults wrong, and that's just terrible for, we expect JavaScript to live for a long time. That's just terrible for everyone to have to do forever. And that's why we said that, and this was again part of my 1JS proposal, that the key here is not to force people into an opt-in. The key is to tie it into the development model that I hope people will actually want to use, and that is modules. So modules in ECMAScript 6 are strict by default. Now that doesn't mean that they also turn on a whole bunch of language changes or anything like that. It's just strict mode. That's the only difference. It's really important for modules to actually be, again, have that smooth path where you can take your code and you can move it into a module and everything still just works fine. But they're strict by default. And if, as I hope, and I'm willing to predict, everyone's going to want to write their code in modules in the future, then we can kind of move away from having to think about this slow, make sure to turn on the strict flag. It's actually my hope that in the future, once everyone's writing the vast majority of their code or even all of their code in modules, strict will even be a concept that can be forgotten. It'll just be like bad practice to write code that's not inside of a module anyway. So the TLDR of 1JS is that features are better than forks. If we want to pave better paths for the future, we need to add features that are orthogonal, that are composable with the existing features so that people can feel confident that they can adopt them into their existing code bases without fear of perturbing the rest of their code base, and that forks are completely hostile to evolution. And modules are a much better programming model. They get the defaults better than modes. All right, so the last topic I want to talk about is the extensible web. I guess in this community, at this point, okay, how many people have heard of the extensible web? Okay, like maybe half, 2/3, something like that. So the extensible web is really a movement about the process of how we evolve the platform. So I've given a couple examples of places where I think evolution works better, where evolution is a good thing to use. And I think the reason for that evolution is successful is because we have healthy competition between browsers right now. We've actually got a lot of browsers, so that means they're this engine that we can tap into to evolve the web. as contrasted with 1998 when Netscape had to do this Hail Mary pass to try to save the web. But as far as the process goes, evolving the web means figuring out how to do the design process in the context, this very strange context of the web marketplace, of the browsers and the standards and the strange ways that they operate. So to me, a really key part of this and understanding how this has to work is understanding how the design process itself works. In my way of looking at design, maybe the two most important things that go into good design are that you have to think about the big picture in terms of use cases, workflows. You have to think about how the end-to-end system works. You really have to be able to zoom out and see a coherent whole. But you can't actually build a development platform without small, orthogonal, composable primitives. These are terms I've heard over and over again at this conference, and it has made my heart sing. This is the first conference where I've actually heard people freely use those terms without being laughed off the stage as academics. So I think those are absolutely critical parts of the process. But these are kind of in tension with each other. One is the big picture, and one is the sort of zoom in. So there's a concept from philosophy called the hermeneutic circle, no relation to my name. And I'm not a philosopher. I took just enough philosophy classes in college to be dangerous, so I'll probably get this entirely wrong. But my understanding is that it originated in theology, but the idea has sort of been adopted into several different philosophical areas, including like literary analysis, I think even epistemology. To me, as an armchair philosopher, it actually explains so much about how I work and how my thought processes work. So when you think in terms of literary analysis, the hermeneutic circle says, well, you can't understand a text unless you actually read and study the text. It's obvious, you got to read it. But then once you've read the whole thing, you can interpret it and you kind of get a better picture of the whole. You sort of understand the big picture. But once you've got that new understanding of the whole, you can actually go back and reread it, and you'll have a deeper understanding of the parts that you're rereading. And then in the process, that's going to give you a better picture of the whole. And you kind of go around the block several times until you are refining your understanding and getting a richer and deeper understanding of it. I think to some people this is kind of a scary idea because it feels like, well, how do you know that you're done? I think there's a sense of when your trips around the block are getting quicker and smaller and the deltas to your understanding are getting smaller, that you have a feeling of, all right, it's ready to ship. This is exactly the same as how, in my mind, the design process works. We design the pieces. We come up with these primitives that are trying to implement the things that we need to implement. But then in the process, we have to evaluate that against the constraints and requirements that we set out for the design space and make sure that that end-to-end user story, those workflows, the big picture actually makes sense. And in the process of evaluation, we realize that there are problems with the primitives. We have to tweak the primitives. We have to go back and revise them and go around the block several times until it actually feels like it's matured to the point where it's ready to ship. So this is not really new to the software world. This looks very much like the iterative process or any variations on the iterative process. And we have a healthy, not entirely healthy culture of moving fast and breaking things in the software industry. And this is not ill-motivated, right? Like iteration, being willing to break the way it worked before to make it better, that's an important part of the process. But when you're building a product, that might make sense, depending on your particular kind of user base. You build the product for a while, you say, oh, this is ready for users to start using it, you ship it, you get some evaluation and user feedback, that gives you a better sense of what's not perfect about it, and you go back around and you build it some more. And that's cool, like that works when you're doing a web app and like you can push out changes to it anytime you want. But I'm talking about standards here, and standards are funny. So if I tried to do this exact process with a standard, I'd say, okay, let's design it. This is cool. We're figuring it out. Time to ship. We'll ship it. Now we'll get some evaluation and feedback. And oh, wow, it's totally broken, but can't touch it. We'd break the web. So iteration does not work once you ship a standard. So in my mind, this is the problem that the extensible web movement is trying to solve. And that is that we can't do good design without an iterative process, but we can't do an iterative process by waiting until we've shipped a standard to get feedback and evaluation. We have to get that evaluation as part of the process, just like any other human thought process that involves iteratively refining your understanding of things and polishing your design. So this is where you guys come in. I've been talking about standards. I've been talking about what I do, but this is the part where developers have to be part of the process, and I think the process has a lot of flaws where it has not involved developers nearly enough. So the picture of how standards discussions usually go, historically especially, it's been getting better. But historically, it was like you had these browser vendors, and they were having a big debate about what capabilities the platform needed, and they would argue for a while, and they'd come up with something, and then they'd start to ship things, and then the browsers would all compete with each other until things settled, and then eventually it would land on the web, and developers would start to use it. Or occasionally, you'd have a few incredibly hardy developers who put on their asbestos armor and dove into the mailing lists and survived the flames. But there were few and far between. So we need to make this better. We need to get developers involved in this process. But one of the things that has been really exciting for me, particularly in the process of working on modules with Yehuda, is I have seen a better model. I've seen it work. So what we did with modules, after several years of me flailing around and making some mistakes, was Yehuda got himself involved. He started working together with me. We started refining the design based on a conversation between the perspective of a browser vendor and the perspective of a developer. And then really critically, people started building it. There's the ES6 module transpiler, and people started actually using it, and the Ember community has actually been totally critical. I don't know if how much people actually realize this, but it's been totally critical to this process. I'm running out of time, so I'm just going to wrap up really quickly. The other piece I just want to point out here is that if you look at kind of the incentives driving these two constituencies, browser vendors, what they are on the hook to do is to ship features. They have to just get stuff out there, and they have to build it. So they're thinking about the constraints about how can I get it out fast, how can I get it implemented performantly, how can I get it implemented securely. You've got developers who are saying, I've got to build some software, and I just need to make sure that I can ship my apps. But nobody's necessarily on the hook for actually figuring out what is the development workflow, what is that user model for the web developer. So one of the things that, one of my goals in this process is to have the development workflow become a part of the conversation. And again, I think Ember has really been modeling this. Yehuda has been an incredible force on TC39 for getting people to think about this. I've certainly learned a lot from it. But I think this is something that needs to become a part of the process. So the key story for how the extensible web works is we got to make sure that those missing primitives are in the platform so that it's possible to build things in userland. But we got to do that as fast as possible so that people can start to experiment in userland with polyfills and compilers. Then we have to get developers and browser vendors together working on these things in conversation from the beginning. So as much as it's been too far to one side that it's been all browser vendors, some people get this perspective of, oh, the browser vendors should just add some primitives and we'll do everything in userland. And I don't think that's the model either. I think it actually still needs to involve the browser vendors because they ultimately are going to be doing the native implementation, and they need to think about performance. They need to think about security. They're a stakeholder, and they have other perspectives that web developers don't necessarily have, but the two have to be working together. But together, I think that's the way that we need to design the future of the web platform. And I think the Ember community has been an incredible model for how that can work. And that's all I got. Thank you very much.